Okay, so we've looked at number problems, we've looked at area and perimeter problems, and we've looked at money problems or value problems. Now we're going to take a look at the last two styles of problems. So the first one is going to be mixture applications. When we're dealing with mixture applications, it's going to be somewhat like our value problems. So in this case, if we see that cashew nuts cost $22 a kilogram, are mixed with Brazil nuts, which cost $16 per kilogram, then it says the total weight is going to be 50 kilograms, and the price for the weight is going to be, for the combined, is going to be $18 per kilogram. So the first thing I'm going to do is I need to define my variables. Well, I'm going to say that C represents the kilograms of cashews. I'm going to say that B represents the kilograms of Brazil nuts. Now, for my equation 1, I'm going to pull that from the first part. I'm going to pull that from the weight. So if I said that C is the weight of the cashews, B is the weight of the Brazil nuts that I purchased, then I'm going to say that equation 1 is going to be the weight of the cashews plus the weight of the Brazil nuts is going to equal the total combined weight of 50. I'm going to say that for equation 2, it's going to be, in this case, the dollar value of what I have. Well, the dollar value is going to be the weight multiplied by the cost per weight. So the dollar value of the cashews is going to be $22 divided by the weight, or dollars per kilogram divided by the weight. For the Brazil nuts, it's going to be $16 per kilogram multiplied by the weight. And the last part that's really important is the total combined is going to be the cost, average cost per unit, $18 per kilogram multiplied by the total weight of the purchase, 50. This is the most important part we need to consider. And now we can solve it just like we would in any of the other cases. I'm going to say that in this case, I'm going to isolate B. Doesn't really matter which one I isolate. And I'm going to say that from equation 1, B is equal to 50 minus C. And I'm going to substitute that into equation 2. So 22C plus 16, 50 minus C is going to equal 18 times 50, or 900. So 22C minus 16C plus 800 is equal to 900, or 6C is going to equal 100 when I move that one over, which means that C is going to equal, and I'm just going to leave this as a reduced fraction, 50 over 3. If C is equal to 50 over 3, put that back into this equation, and B is going to equal 50, or 150 over 3 minus 50 over 3, which means that B is going to equal 100 over 3. Now, if it wants me to give this as a rounded answer, it's going to be approximately 16.3 kilograms of cashews and, sorry, not 16.3. Oh, that's right. 16.3 kilograms of cashews and 33.3 kilograms of Brazil nuts were purchased. If I'm looking at another type of mixture problem, in this case it's a chemistry style mixture problem. So Earl has to make 180 milliliters of 60% hydrochloric acid solution. He has 1 liter bottle of 45% hydrochloric acid and a 1 liter bottle of 70% hydrochloric acid. How many milliliters of each solution are mixed to make the 180 milliliters of the 60% solution? So, the first thing I'm going to say is that I'm going to represent X and Y. X is going to be the milliliters of 45% HCl solution, and Y is going to represent the milliliters of 70% HCl solution. Now I'm going to have my two equations. Well, if I know the milliliters of one plus the milliliters of the other is going to equal the total milliliters that I'm going to use, which I can pull from here, then I'm going to say that X plus Y is equal to 180. The second part is if it's a percentage of acid, then I'm going to state the next one isn't going to be a value one, but it's going to be how much actual acid there is in each of them. Well, if X is 80% acid, or the one in X, sorry, not 80, yes, 45% acid, then I could say that if I take 0.45% of the amount of milliliters I used for X, that's going to tell me how much actual acid I'm getting from X, plus 0.7 Y, that's going to tell me the amount of acid from Y, and this is going to equal 0.6 of the total 180, because 60% of that 180 milliliters is actually going to be acid. And then I'm just going to solve it the same way that I did the last one. I'm going to isolate one of the variables. So I'm going to say Y is equal to 180 minus X. And then I can say that 0.45X plus 0.7 180 minus X is going to equal that 0.6 multiplied by 180, or 108. I can multiply this out and say that 0.45x minus 0.7x plus 0.7 multiplied by that 180 is going to give me 126 is equal to 108. This is going to tell me that negative 0.25x, and then I'm going to subtract the 126 from each side, is equal to negative 18, and divide by sides by negative 0.25, and x is going to equal 72. Put that back into my other equation. Y is equal to 180 minus 72. Y is equal to 108. Earl used 72 milliliters of 45% HCI solution and 108 milliliters of 70% HCI solution.